Hello, everyone. Welcome to our second Ice Day video. In this one, we are going to take a closer look at geminal diols, and in particular, how they are a key part of an old mechanism from last semester. If you saw the first Ice Day video from earlier today, you'll recognize this AI-generated image, and remember how a certain molecule in carrots is critical for vision by mammals, like humans and this cute little bunny. In particular, you'll recall that 11-cis retinal, the key molecule in mammalian vision, is a terpene, a plant molecule that we obtain from our diet through such molecules as beta-carotene that we get from carrots. But what I want to do is I want to take you back to last Thursday, where we were talking about geminal diols. Geminal diols are molecules that have two OH groups bonded to the same sp3 carbon. They are analogous to hemiacetals, except that water is attacking a carbonyl of an aldehyde, for example, instead of an alcohol. Now, the thing to remember about this is that we're not going to go through the mechanism, but it involves the same mechanism as hemiacetal formation. It's just water in place of the alcohol. In other words, it's mechanism D. But what I want to draw your attention to is that except for formaldehyde, the simplest aldehyde, equilibrium does not favor formation of the geminal diols, yet they are in equilibrium, they do form. So even though all larger aldehydes have most of them, the molecules in the carbonyl state, not the geminal diol state, we still have to think about them as being present, especially if there's water and acid around. Okay, why is that important? Well, I'm going to take you back to last semester. And we talked about a reaction, the chromic acid oxidation of alcohols. The chromic acid oxidation uses this reagent, H2CrO4, which is actually created from adding CrO3 and water, lots of water, with H2SO4. You can also add dichromate instead of the CrO3. But the point is, those combine and create H2CrO4. The reaction involves an initial oxidation of a primary alcohol to get to an aldehyde, and that's what I want to talk about. So think about it. We've got water, we've got sulfuric acid, and we've got an aldehyde. And I just told you that that aldehyde is going to be in equilibrium with a geminal diol. Now, the geminal diol is not favored, but it's there in some amount. And because of that, another one of the OH groups reacts with the chromic acid. And when it does so, it creates a carboxylic acid. So there's a couple of points about this I want to make. Number one, that here we are last semester. I told you we talk about this. See, it says we'll learn about this next semester. We just did. That we have an aldehyde, and even though it's in equilibrium with a small amount of geminal diol, that geminal diol does allow reaction to proceed all the way to the carboxylic acid. The second thing to remember is that aldehydes, even though it's not what we focused on last semester, aldehydes will react with chromic acid to create carboxylic acids. This is something that came up in the last homework. We also can explain something from last semester that I said that you would just have to accept. And that is, if we create a chromic acid type reagent that does not have water, if there's no water present, then we're not going to get any geminal diol. If we don't get any geminal diol, then the reaction cannot proceed, so we stop at the aldehyde. So chromic acid will take a primary alcohol all the way to a carboxylic acid through the aldehyde. But PCC is a chromic acid-like reagent that does not have water in it, so there is no geminal diol formed, and it stops at the aldehyde, and that's why PCC gives you aldehyde with primary alcohols. PCC or chromic acid will take a secondary alcohol to a carbonyl. And I just want to remind you, sure enough, that because we didn't start with an aldehyde doesn't mean that an aldehyde won't react. It does react. An aldehyde reacts with chromic acid to generate a carboxylic acid. So even though it wasn't the point of the mechanism, it is there, pretty obscure, but it is there. And so I want you to remember that, because this semester, we're going to deal a lot with aldehydes, and the whole next chapter is carboxylic acids. So you're going to want to remember this reaction. Okay, I hope this was helpful.